Hi everyone, today I will talk about multi-governance model risk management. Now, if you ever tried to automate a validation, then probably you will agree with, say, the results of this poll that we run during Yields Innovate, our own event. And this was actually during a presentation of Philip Royce, who presented how HSBC has automated model validation using Yields. So the results of that poll was that actually, if you need to automate a validation process, the main hurdles are not technical, but rather operational. So coming up with a structured process for validation is where all the difficulties are. And the reason for this is that models differ a lot if you say start looking at a credit risk model, and then you compare how that is managed with, say, a model that is using valuation, then you'll see that both the life cycle as well as the metadata is very different. And that makes standardization very hard. And standardization is the single feature that is important to be able to automate at scale. If every validation is different, then it's going to be very hard to gain efficiencies by automating the processes. Similarly, if we look at how our own implementation plans are, then you will also see that the deployment or making available the platform is very easy. Here, it takes like 1 month, and it could actually even shorten to just a week. However, where we do need a lot of time is in what we call the configuration stream. And actually, that means that we need to align the setup of the platform with the model risk management framework and the standards and procedures of the customer. Now, actually configuring the platform itself is not that hard either. What is challenging, on the other hand, is that we always have to agree on all the fine details of the processes. We have to agree on how models need to be structured, how their attributes are represented, what's the workflows related to model findings, and so on. So coming up with an agreement that is kind of covering how the bank wishes to operate, this is again where the issues are, because you have to go through all of those details with all the different users. And very often during such an exercise, you discover that actually there are subtle or less subtle differences between teams. And again, that makes it harder or more work to actually bring the platform in line with the current practices. Now, simultaneously, we also see that this problem is actually growing because there is more and more AI use cases that need to be managed. This, of course, is caused by, first of all, the fact that nowadays we store use cases in the inventory. This means that we take a model and we attach to it the context in which the model is used. For instance, if I'm using ChatGPT to create documentation, then the model is ChatGPT. The context, the usage, as we will later call it, is actually creating documentation. And it's this context that drives the risk, and therefore there is many different use cases, even if you only use a single generative AI system. Now, simultaneously, everyone these days can create their own AI assistant. For instance, if I take ChatGPT, I can create what is called a GPT, or a project where I store some additional context and where I somehow add an additional prompt to be able to use ChatGPT in a very specific case again. So here we see that the number of AI systems and the number of AI use cases as a consequence increased quite a bit. And on top of that, of course, we have continuously new guidelines coming up. So this means that actually the scale of AI governance increases a lot. And if we do not want to scale exponentially the teams and still want to keep risks under control, then this means that we need to lower the unit costs of AI governance. Now, this is primarily an organizational challenge, as I will explain. And the reason for this is that standardization is hard, because if you need to standardize your practices across the entire organization, then it means that you need to decide everything by committee. And as we all know, committee decisions are not that easy. Now, the consequence of this is that we often lack the ability to properly push automation, because that again requires standardization. And if you look at, say, the results of a recent survey by Deloitte, then you can see that there is a big gap between what people would like to automate versus what is actually being automated. And this is here shown as the dark green blocks are those aspects that have been automated already. The lighter green ones are the ones that they would like to actually automate. Now, this is for validation, and as you can see, there is a big difference between what one wishes to do versus what is being realized. And actually, this is the issue not just for validation, but basically for every aspect of model risk management. Now, that's why together with BNP Paribas, we developed the concept of multi-governance model risk management. And today I would like to explain a bit what this is. Now, if you start with one example, an AI team and a classical model risk management team, then you will see that actually the requirements of both teams are very different. On the one hand, model risk management and, for instance, credit risk or IRB models, they have very strong, complex processes. They also have huge documentation requirements, and as a consequence, they evolve fairly slowly. Simultaneously, on the AI side, we have often very light touch governance needs because there is often less requirements from the regulator. The speed at which those systems evolve is huge, and the requirements regarding, say, documentation are often relatively minor. Now, if you need to align both requirements to fit them into a single inventory, basically, then you would have two possible scenarios. On the one hand, you can try to create one policy and one framework that covers the needs for both. But most of the times, this will lead to some sort of a compromise that no one will really like. On the one hand, you'll end up with something that is probably too heavy for the AI teams, but on the other hand, it's going to be way too simple for the model risk management context. Now, of course, you could also then say, look, it's impossible to create a single system. Let's just create two different systems, even maybe with two different vendors. But the challenge here is that will lead to duplication, because often you might have to share or a model between both governances if it is relevant for both. That also implies that it's going to be way harder to do knowledge sharing, because often the teams might actually need to create very similar models. And ultimately, if you want to try to solve that in one way or the other, it will require integration between two systems, which again make it harder to support the entire thing from a technological point of view. Now, that's why we have introduced multi-governance, which kind of tries to strike a balance between both extremes. And since we are a Belgian company, I would say that this is a nice example of an actual Belgian compromise. Good. In reality, I'm afraid that it is going to be still yet a little bit more complicated than what I just described, because if you look at an actual large bank, then you will see that there is not just two frameworks or two governances, AI and model risk management. No, typically within model risk management itself, you have different policies and standards, probably by like business lines or business activity, and sometimes even related to different geographies as well. So it can be, for instance, that historically you started with a global policy, but then you noticed that actually credit and operational risk were a bit different. Therefore, there is specialized policies being introduced. And then when the US entity starts having, say, a sufficiently large scale, you might need to kind of align all of this again with SR 11.7, but then that's maybe not 100% aligned with the European standards, and therefore you create a US policy then for both types of models. And at some point, maybe you start an insurance division, and then you'll need to create an insurance policy. But then actuarial models are very different from classical financial models. Therefore, maybe that requires another policy as well. And as you can see, the complexity of all of this increases. On top of that, today we have AI being used in all of those verticals. So that means that actually an AI governance is probably needed as well. And if you then think of one model, like a credit scoring model, that would be using a machine learning algorithm, then suddenly you see that actually that single model falls under multiple governances. And that's what makes everything so complicated. Now, if we then think about this a little bit more holistically and we try to enumerate what are, say, the key system requirements that we would have to build a system that can deal with this complexity, then there is a number of them that are really important. The first one is that you do not want to have duplication. You don't want that if a credit risk model uses machine learning, that suddenly I will have to have two entries in the inventory, one to track what happens in the classical credit policy, and then another entry that tracks basically what's the status according to the AI governance. Secondly, if I am a data scientist, I'm used to see machine learning algorithms in the way as it is described by my AI policy. While if I'm a model risk manager, probably I have different expectations. If I log into the application, I would really need to see just what I need, and I don't want to see attributes or processes that are not relevant for my own governance. Third, as I explained in the beginning, standardization is very hard given all the complexities of a large organization. Still, it's good to be able to push for it or to motivate people for it, but it cannot be like a blocker because often it just requires too much time to align everyone. Therefore, the application should actually favor standardization, but it shouldn't block a user if it is impossible to get a compromise and to get everything standardized. And then finally, if since these objects can be shared, there is the potential for teams to learn from each other's work. So being able to browse other inventories and somehow use an already existing model in a different context should be made easy. Now, as I mentioned with BNP Paribas, we developed this approach, and actually we landed on a representation where the use cases are what we call triplets. They contain a model which has a version. On top of that, we specify the usage, which is basically the business context in which something is used. And we also specify the governance, which is really the oversight framework that determines the life cycle, the model attributes, as well as the stakeholders. So this triplet itself is an inventory item. And if I have, say, the same model being used in the same context but in a different governance, then that will be two triplets in the inventory. However, the underlying model itself is the same object, so we avoid duplication. So this triplet, or use case as we call it, is really the base, the starting point of the approach. Now, if you would look at this in a simple example, suppose I have a probability of default model, and that's actually the model with version 1.2. So then I can associate different usages to it. So maybe that model has been used in the credit governance for both RWA and IFRS 9. And in that case, we need a number of attributes like the name and some weights. And probably in this credit governance, there is different processes such as a specific risk tiering and a particular validation process. Now, if the same model would also be used an AI, like under the AI governance, because, say, the model itself, the probability of default model, is a machine learning model, then again, I would have to associate a usage to it, but maybe some of the attributes are different. Like maybe I need I need an ML flow identifier to show or to point users or model risk managers to the right experiment that has been used to prove this specific model. So as you can see, while it is the same model and even the same version, the attributes or how the use case looks like can be different. Simultaneously, probably in this AI governance, the processes are different as well, as you can see in the red box. And then finally, if I am a particular user, like if I'm a governance officer focusing on IRB, then probably I will have access to those first two triplets, while if I'm in AI governance, I only want to see that third triplet. However, if I am the head of the entire risk team, then I need the global overview. And if I open the inventory, then I should see all three triplets or use cases together. Now, how do we actually implement something like this? Well, the first aspect is that we are using what we call templates. So a template determines how a use case is shown, like it determines which attributes are displayed. Moreover, templates can also have conditional fields. The reason why this is the case is that, for instance, when you do risk tiering, then if you have a high risk tier model, then probably you need to capture more information than if it's a low risk tier model. So in that case, those extra fields can be made conditional to the risk tier. So on top of that, we associate a model type to a template so that, say, a probability of default model can be differently shown than a pricing model. However, you often want to group models together. So we also have a concept of an object group, which basically groups together different types. So if I want one model inventory that contains both credit models and valuation models or pricing models, then I would have those two model types, credit and pricing. But both types would be associated to the single inventory group model so that I have a single inventory. Now, determining how an object in the inventory looks like is typically defined in the governance. So that's why the templates themselves are specific to a governance. And the attributes that we use or that we allow in the templates can be anything. It can be simple, but it can also be structured text, and it can even be pointers to other objects. Now, as I mentioned, we don't store models directly, but we store triplets. And those triplets, as I said, are, or we also call them use cases, and so they contain both the model with its version, the usage, and the governance. Typically, the templates for the use cases are the same when you stay in the same governance, but you have different usages for the same model. However, when you move to another governance, then typically the templates are different again. Good. If we look in our own application, then here is a few screenshots about it. So this is a view from the AI governance, and as you can see, I have like a number of different inventories. If I switch to the credit governance, then actually the inventories that are available are already different. And again, this is driven by the governance itself. However, if I look at all of this as, say, the head of model risk management, then I can see across the different governance. So as you can see, there is the same use case here, the same model, but associated to a different governances, either model risk management or AI. And to give you an idea of how templates look like, so this is one example of a template where you have a number of attributes that are defined. And on the other hand, if I go to another template, in this case here, one for an LLM, then as you can see, there is a lot fewer attributes that are shown. This is driven by the template itself, as I already explained before. Now, the key point is that once you have a use case or a triplet, then there are many operations that you can do on it to create other triplets, right? So first of all, I can add a usage, meaning I have a use case. That same model is now being used in a different business context. So I basically add another usage, which creates another triplet automatically, and all the fields are automatically populated in this new triplet as well. Secondly, I might upgrade the version of the model. In that case, I probably also carry over some attributes already when I create a new triplet, but potentially others might be different. So if I have, say, a minor change in the methodology, I probably will keep the same controls and the same assumptions, most probably. However, I need to update a bit the methodology description itself in the triplet. So this can also be automated, so you can link attributes or copy over attributes from one triplet to the other, and this makes it easier to manage all of that information in an efficient way. And then finally, you can basically also start using the same triplet, the same model and usage in a different governance. Of course, these are like the simple ways of creating new triplets. It's also possible to change more than one dimension simultaneously. For instance, I have a model that is used in a particular usage in a given governance, and then I change both the usage and the governance in one go. That's also possible. Now, an efficient inventory typically also needs other types of objects. We have seen quite often already the concept of what we call a platform of a factory. And this is really a set of objects such as models, tools, and components that work together to allow a user to build a use case. It's like a framework which you can use to build your own use case. Again, simple example, as I explained in the beginning, is a GPT with OpenAI. So I give some knowledge and context, and I add ChatGPT on top, and that determines a new assistant, for instance. So in that case, the OpenAI platform is what we call the factory here, and it consists of plenty of different components, and I can create a use case from it. Now, those components can be many things. So what we define then as a component is really a mathematical algorithm that I wouldn't call a model, because maybe it never can be used in isolation. For instance, an embedding, right? I'm like in 99% of the cases, at least, I will not use an embedding standalone. However, if I look at a pricing model and a market risk model, then that pricing model is what we would call a submodel. It can be used standalone. However, in the context of the market risk model, it's just a component of it. And then often you also have IT assets. All of these can be separate inventories, and with their own dependencies, and you can have composite objects such as platforms. Now, why is this important? Well, if you have this granular view, then you can start thinking about running governance processes at different frequencies. And this then allow you to kind of implement a governance that is efficient. If you take the example of an AI assistant platform, like the example that I gave with ChatGPT, then the way we work is that the platform owner would have very strict requirements about the validation and the revalidation of the entire platform itself. So with plenty of controls that are being put in place, with also a high frequency of revalidation whenever one of the constituents changes, and a lot of extensive testing and document requirements. So it's hard work to be a platform owner. Simultaneously, if I'm a platform user, if I want to use the platform to create my own AI use case, then that actually should be simple and easy. So here, The idea is then for the users who create a use case from the platform, they inherit basically all of the testing that has already been happened by the platform owner, and there is very small light requirements for the use case owners themselves. This is kind of done by the governance itself. However, it's also very natural to organize it like this, because if, again, in my AI assistant, when I create the use case from the platform, then I basically define very precisely the context, like I have all the knowledge, I have all the prompts and all of that. And that information allows you to often automate quite efficiently the testing and the monitoring of the use case itself. So that itself can also be more easily automated, leading to more efficiencies and lighter touch governance efforts for the use case owners. Now, we can, of course, try to quantify a little bit how much efficiency you can gain if you are organizing your inventory in the way that I just explained. So let's take one very basic example. You can use your own numbers to make your own estimates based on the same logic. So suppose we have 200 use cases in credit and 200 use cases in AI. Now that means we would have 400 use cases in an inventory, which is quite a considerable amount of work to properly periodically revalidate. However, if we look a bit closer, then we see that, let's say, every model has approximately 3.5 usages associated to them. So basically, for each model, I will see 3.5 use cases in the inventory that use that specific model. Very often, when you look at those statistics, you will notice that, say, for classical models, the amount of usages or context is relatively small. For AI, it's often a lot more diverse, because you can use AI basically everywhere. Now, suppose then that, say, 15% of the models is actually shared between both governances. And in order to come with some sort of a relative estimation of the effort to implement governance for those 400 use cases, I'm using story points. So this can be whatever, right? It can be a day or a month. It's just like one unit of work concretely for your organization. So if, say, managing a single use case would represent an effort of 1 story point, then probably a model, which is a bit more generic, will require double that work. However, the usage itself, which is more like the abstract context, should be very light to maintain. Let's say it's 0.2 story points. So if we then do the math, then those 400 triplets can actually be decomposed in 109 models and 65 usages. So that's 170 objects. So that's a reduction of around 56% that you can already implement. But what is more important, if we compute the relative reduction in effort, then actually the effort to maintain this lower number of components and simpler components in the case of usages drops by over 40%. So this is really a significant improvement. Good. And this brings me to the end of my talk today. So as I explained in the beginning, the amount of AI use cases is increasing tremendously. If we really want to mitigate the risk, this means that we will, first of all, have to make sure that everyone understands what AI governance means. But we also need to think carefully about the domain model, like how are we going to represent those AI use cases to efficiently manage them. And one solution to that problem is multi-governance model risk management. Thank you.